All right, let's get into it. Today, we're going to crack open the gadgets that basically run our entire world. And we're going to look at the tiny, little components that make it all happen. We're going to go from this perfect, ideal world of how electronics should work to the messy, gritty reality of a hidden war being fought on a microscopic scale. Let's dive in. So, you've all seen a circuit board like this, right? It's the brain, it's the nervous system of pretty much every piece of tech you own. But what if I told you that inside this little city of tiny parts, there's a constant battle being fought? A battle between what's real and what's fake, that some of these components might just be imposters in disguise. Well, to understand that, first we've got to understand the good guys. Okay, so let's start with the absolute fundamentals. Before we get into all the crazy stuff like counterfeit parts and datasheets, we need a solid grasp on how these little guys are supposed to work. And you know what? The best way to do that is to just forget about electricity for a second and think about something way simpler: water flowing through pipes. First up, we've got the resistor. Its whole job in life is to control the flow of electrical current. So in our water analogy, a resistor is just a narrow section of the pipe. See? It doesn't stop the water completely, it just limits how much can squeeze through at any one time. Super simple, right? It's basically the traffic cop of the entire circuit. Next, we have the capacitor. This little component stores energy. I want you to imagine a flexible rubber sheet stretched right across the middle of our pipe. As water pushes in from one side, that rubber diaphragm stretches out, storing up all that pressure. Then, when the pressure outside drops, the diaphragm snaps back, pushing the water out. That's a capacitor. It stores and then releases electrical pressure, which we call voltage. And our third key player here is the inductor. Now, this one is all about momentum. Picture a really, really long, heavy fire hose that's completely full of water. When you first turn on the tap, it takes a second for that huge mass of water to even start moving, right? And once it's flowing, it doesn't want to stop instantly either. An inductor does the exact same thing with electricity. It resists sudden changes in current. It acts like a kind of electrical flywheel. Okay, so those water analogies, they're fantastic for getting the basic ideas down. But let's be real, engineers aren't designing our phones using plumbing diagrams. They use something way more complex and honestly kind of scary: the datasheet. This is the official rulebook, the Bible, for every single component out there. And hey, if you find these things totally overwhelming, you are not alone. As Kyle Hunter from Microtype Engineering says, even for the pros, diving into one of these documents for the first time can be absolutely terrifying. They're dense, they're packed with charts and numbers and jargon, but believe it or not, there is a method to the madness. So how do the professionals actually tackle one of these things? Well, they definitely don't read it like a novel, from page 1 to the end. No way. They have a strategy. First thing, they jump straight to the typical application circuit. It's like a cheat sheet that shows the part in its natural habitat. After they get the big picture from the descriptions and figure out the pinout, they zoom in on one of the most critical sections: the maximum values. And this right here is so important. The absolute maximum ratings are not goals. They're not targets. They are hard limits. If you exceed them, even for a split second, you can literally destroy the component. Poof, gone. The recommended operating conditions, on the other hand, that's the safe zone. That's the happy place where the part is designed to live and work reliably. Mixing these two up is a recipe for smoke and disaster. So, you've done all your homework. You've totally mastered the datasheet. You understand all the limits. You've designed your circuit perfectly. But there's a problem, a huge one. What if the little component you're holding in your hand isn't what it says it is? What if the datasheet, the markings, the part itself, is just a lie? And this is where our whole story takes a very sharp turn. We are now entering the shadow economy of electronics, a massive global industry that is dedicated to creating and selling counterfeit components. And this isn't some small niche problem. It's a hidden epidemic that affects everything from the phone in your pocket to critical military and medical equipment. It's a huge deal. So what exactly makes a part counterfeit? Well, the key word here is deliberate misrepresentation. A counterfeiter will take one part, maybe it's old, maybe it's been used, maybe it's just a cheaper model, and they physically alter it to look like something it's not, something newer, more expensive, or more reliable. It's fraud, plain and simple, just on a microscopic scale. And the methods they use are, well, they're disturbingly sophisticated. This isn't some guy with a rubber stamp in his garage. It's a serious operation. There are really 3 main techniques that counterfeiters use to cook up their forgeries: relabeling, refurbishing, and repackaging. Let's break down how each one of these works. Okay, so relabeling is the most common. They might literally sandblast the original markings right off. Or, even more cleverly, they'll apply a super thin new layer of black epoxy, a process they call blacktopping, to create a perfect, fresh surface for new fake laser markings. Then there's refurbishing. This is where they take used parts pulled from giant piles of e-waste, clean them up, and re-tin the little metal legs to make them look shiny and brand new. But the most extreme method? That's repackaging. They actually use chemicals to dissolve an old component just to salvage the tiny silicon chip inside, and then they mold a completely new plastic body around it. It's wild. So you're probably wondering, given how sophisticated these fakes can be, how on earth can anybody spot them? Well, the fight against counterfeits has basically become its own high-tech field of forensic science. And it all starts with a simple visual inspection. That is, if you know what you're looking for.
Here are some of the classic telltale signs. Counterfeiters, they often make little mistakes. You might see spelling errors, maybe the logo looks a bit off, or the font size is inconsistent. The process of sandblasting or blocktopping can actually fill in the tiny little mold cavities from the original manufacturing, or it can make the surface texture unnaturally smooth compared to a real part. And the leads, the little metal legs, they might show signs of being scratched up and then hastily recoated. These are all huge red flags.
But the undeniable proof, the smoking gun, is almost always hidden inside. Look at these two X-ray images. On the left, that's a genuine component. See those super fine lines? Those are the internal bond wires connecting the silicon chip to the outside world. Now look at the counterfeit on the right. It is a total disaster. Wires are missing, they aren't even connected. This part is fundamentally broken. It might pass a really simple electrical test, but under any real stress, it would fail, and probably fail catastrophically. And beyond visual checks and X-rays, the real front line of defense uses tools like this one, a handheld XRF analyzer. This thing is amazing. It uses X-ray fluorescence to instantly read the elemental composition of a part's materials. It can tell you if the metal plating on the leads is the right stuff, or if a part that's supposed to be lead-free actually contains lead, which would reveal it as an older, relabeled component. There is just no hiding from a tool like this. And that really brings us to our final thought. Every single piece of technology we rely on every single day is an act of trust. Trust in a global supply chain made of trillions of components that we will never, ever see. The fight against counterfeits is this constant, high-stakes battle to make sure that the very building blocks of our digital world are exactly what they claim to be. It makes you wonder, doesn't it? In this vast, invisible world, how can we ever be completely sure what's real?